Hello everybody, this is Hadi Sagur, PhD in medical physics from Iraq. I'm so glad to be part of the 17th International Conference on Research in Life Science and Healthcare, and I want to thank the Healthcare and Biological Science Research Association for the support during uh, this conference. I'm here going to calculate the electrolytic activity for my biosensors, and here we have a rational introduction and some result. The rational or the interest part in our work is diabetes, and as you see in this global map, the number of people living with diabetes. So in the near future, 2040, almost going the number of the diabetics will be 642 million. This is based on the International Diabetes Federation. And in my country alone, in Iraq, we have 7 million people, Iraqi people, live with diabetes. This is based on the Minister of Health in our country in 2018. In addition to these, how complicated the situation is around the globe, we have in our market a glucose meter, right? And we have a glucose meter or glucose biosensor itself the same. So why we are looking for bringing a new biosensor or a new glucose meter? I'm going to answer this question at the end of this presentation. We all know that the challenge for every machine or device or drug is the cost. And nowadays in the UK, only 9 billion, 16 billion, which is almost 12 to 21 billion dollar, they consume yearly with the NHS. This is based on the NHS calculation. So, and globally, almost 2.5 trillion by 2030 going to be this number. So these huge amount of money shows the struggle of people or governments to bring the good machine to monitor diabetes. So why monitoring is important for this disease? It shows monitoring diabetes, it helps cutting costs. So there is earlier studies in the US shows the ratio of in that country has fallen somewhat from 2.5 to 2.3. And this going to how improve the care and how improve the care could be help cut the costs, right? And the monitoring will assign the early diagnosis. And people with diabetes 2 might be diagnosed sooner, meaning the average person will be less likely to develop the complications. The complication which is very well known as in this list here. So we are here in this research aiming to enhance the electrolytic activity of biosensor. Glucose biosensor basically it's indirect measurement for the sugar. So we put the sugar, the reaction take place between the sugar and the enzyme, and the reaction going to bring electrons. These electrons show up in the screen and shows the level of sugar, but it's basically the number of electron. That's why we are looking for develop the number of transfer electron on the surface of our electrode, which is the same stripper on the glucose meter, and that will do through the connection between multifunctional hydrogel and the soluble cobalt phthalocyanine. And we are then going to bring high sensitivity, high selectivity, and low response time of our electrode or of our biosensors. And in our work, the objectives of this work are going to be produce a multifunctional platform, then fabricate non-enzymatic biosensor. Non-enzymatic because we are looking for develop the conductivity part, not the like enzymatic part. Then enhance the electron transfer activity, which was what we're looking for. And here, this introduction part, this animation shows that biosensors are a selective device, a selective machine. So we can see here, this part represents the recognition element. Recognition element for us here as in biosensor, in glucose biosensor, is enzyme. So when this define the use or the purpose of this of the electrode itself or biosensor itself. And the transducer is the present the technique how this biosensors work. In our work here as a glucose biosensor, it's electrochemical biosensor because we're dealing with liquids. So one of the well-known definitions of biosensor is a compact analytical device or unit incorporating a biological or biological derived sensitive recognition, which is this recognition element, which is going to be associated with physiochemical transducer. And so far, a lot of new designs have been developed to bring a new biosensor, but everyone has like several complications, several pros and cons. So at the end, so far the whole globe deal with the electrochemical biosensor or electrochemical glucose sensor. That's why we are going to study the electrochemical method of our biosensor. The main electrochemical method here is cyclic voltammetry, which is studying the surface of the electrode, and the chronometer was studying also the current of the electrode, which is the current basically is electrons, right? So here shows some equations and the oxidation and the reduction part. And the chronometry is a very powerful method for determining the fusion coefficient on the surface of the electrons. And this figure here, it shows the reaction between the glucose and the enzyme, and going, of course, to produce electrons. And that's why we're looking for to enhance the number of electrons, which is enhance the response of our electrodes to the sugar concentration of the patient. In our methodology, have been done several characterization. These the list of them, and here several equipment have been done working on it. And this part represent the electrode that we've been dealing with, which is based on this platform for the hydrogel with the cobalt phthalocyanine, which is placed on the interdigitated electrodes to calculate the one of the main electrochemical impedance measurement. So, and this is the electrochemical impedance measurement have been done, and here it shows our logical circuit for our electrodes. At the end of this, if we done a lot of we've been working on it, still working on it. We're looking for getting some more result. And for our biosensors, we believe it's more reliable for many in the market and it's cheaper. Also, the time response of it's very short, so it's very quick sensor, very quick biosensor. So I just want to thank those people who've been helping me, Minister of Education and Scientific Research in Iraq, and my college here in my city, Nasiriyah city in the south of Iraq, the College of Medicine in the Thi-Qar University. And I want to thank the Material and Engineering Research Institute, my previous university, my Sheffield Hallam University in the UK. Thank you so much, and cheers.